Very good morning.
Good morning, sir.
A very good morning.
Good morning, sir.
Good morning, sir.
Good morning. Good morning. I have experience in SAP Basis Administration, HANA DB Administration, and also now I am working on SAP BTP Administration as well. So whatever I have experienced in my real time, whatever I have done the activities in my real time regarding to HANA database administration, I'm going to train you all those real-time activities, real-time roles and responsibilities in my training session. For today, we are going with the demo session, and the demo session is also very important for the upcoming sessions as well. So the demo session is all about it's a HANA database. HANA is a database. We also call it as a in-memory database. Why we are calling HANA as a in-memory database? HANA database will store data in disk as well as in memory level. That means HANA database storing data in memory level as well. So that's why we are calling it as a in-memory database. So we have different databases in the market like MS SQL, MaxDB, Sybase, DB2. All those databases will store data in disk. But whereas in HANA database will store data in disk as well as in memory level as well. So that's why we are calling it as in-memory database. And the abbreviation of HANA is high performance, H for high performance, AN for analytical, and A for appliances. So simply we can call it as high performance analytical appliances. What is meant by high performance? What is meant by analytical? And what is meant by appliances? We need to discuss each and every letter of HANA. Coming to first high performance. High performance means whenever we execute any SQL statement, we need to get the data extremely fast. Example, whenever we go for an ATM machine, when we insert the card into ATM machine, we need to get the data on the screen extremely fast. If you are getting with a delay of 5 seconds or 10 seconds or 1 minute, the performance is very low. In the same way, whenever we execute any SQL statement in HANA database level, so we need to get the data extremely fast. So that's we are calling it as high performance. Now we will go with the general example. Okay, we'll go with the technical example. So we have a table and the table size is approximately 5 GB, and assume that this table is stored on any of these databases like MS SQL or DB2 or MaxDB. Okay, and the user is executing a statement, an SQL query called top 5 customers. Top 5 customers means whoever has highest amount, those top 5 customers has to be displayed. Whenever user executes a statement that is top 5 customers on this table, and the time taken to get the output is all about 3 to 4 minutes. Okay. Now the same table, same size of table is stored on HANA database, and the user is executing same SQL statement, top 5 customers. Whoever has highest amount, those customers has to be displayed as top 5 customers. Whenever user executes a statement that is top 5 customers, and this table is on HANA database, and the time taken to get the output is all about 3 to 4 seconds, whereas other database is taking 3 to 4 minutes, while coming to HANA database, it is taking only 3 to 4 seconds. So when compared to other databases, HANA database is giving high performance. HANA database is giving very less time to get the data extremely fast. So when compared to other databases, HANA database is giving high performance, right? What are the reasons behind HANA database to get high performance? The reasons behind HANA database to get high performance are, one is in-memory database, and the second one is columnar storage, and the third one is massive parallel processing. These are the 3 reasons why HANA database is giving high performance. So we need to discuss each and every reason. So then only we can understand HANA database is giving high performance or not. Okay. So now we will go with the first reason called in-memory database. So we have a system, and the system contains a disk. System contains a disk and also memory. Memory means nothing but RAM. And also we have a number of cores, we call them as CPUs. Okay, these are the main components of a system or a computer. Okay, and I'm going to use a database called MS SQL database. So I'm going to store data in MS SQL database, and MS SQL database is going to be stored data in disk. Okay, and I have an application server, so that is SAP application server. and this application server is connected to my database. My SAP application data is stored in database, and the database is MS SQL database, and MS SQL database is storing data in disk level. Okay, and user needs A plus B is equal to 10 data. User needs A plus B is equal to 10 data, and the data is available in your disk level of MS SQL database. So user is coming from SAP GUI. User is coming from SAP GUI, and the request is received by your application server. So this application server part is purely basis part. So I'm not going to be explain here. Just I'm going directly to database. So if whenever user submits the request will come from SAP GUI to application server. So in application server, if the data is not available, if the user requested content is not available, then the request will go to database through DB client. Okay, and the request will come to database. First, the request will be received by CPU, and then the request will come to memory, and then the request will come to disk. User will fetch data from disk level and will go back from disk to memory to CPU, and then back to application server. So this is what the process happen to request or to access the data in disk level. Okay, so to make you understand, I'm going to name it as this is a ground floor. This is ground floor. This is first floor. This is second floor, and this is a third floor. I'm naming it as a number of floors to make you understand. So whenever the request comes from application server to database, okay, assume that this is ground floor. From ground floor to the request coming to CPU, and from CPU to the request is coming to memory, and from memory to disk, user is fetching data and bringing data back to memory, back to CPU, and back to your application. So this is what happened. Okay, now I want to give an example here. Assume that a drinking water placed in third floor, and user is coming from ground floor. Okay, from ground floor to first floor he will come. From ground floor to first floor, and from first floor to second floor, from second floor to third floor, he will drink water and go back again from third to second to first, and first to ground. This is what happened. In the same way, if we place the data in disk level, so the user request will be processed in this way. First the request will be received by CPU. CPU will process the request, and it will use memory, and then it will go to disk and fetch the data and go back to in the same way, and will be given back to your application server, and the data will be displayed to user. This is what happened. Okay, if we go with the MS SQL database. Now coming to HANA database. HANA database will store data in disk as well as in memory. HANA database will store data in disk level and also in memory level. Whatever the data we have in disk, the same data we have in memory level. Okay, so that means A plus B is equal to 10 data we have in disk level and also in memory level. So now user is coming from SAP GUI, and the request will be received by your application server. If the user requested content is not available in application server, then the request will come from application server to database. First, it will process the user request by the CPU, and from CPU, the request will come to memory. So the data is available in memory level, right? So user will fetch data from memory level. Why? Because HANA database will store data in memory, in disk as well as in memory. So the A plus B is equal to 10 data is available in disk as well as in memory. So user will fetch data from memory level and will bring the data back to CPU and back to your application server. Okay, that means user is coming from ground floor to first floor. User is coming from ground floor to first floor to second floor, and fetching data from second floor and bringing data back to first floor and giving back to user. So this is what happened if we go with the HANA database. Okay, now the same example will go for drinking water. We placed in second floor, and also we placed in third floor. Okay, so whenever user is coming from ground floor, okay, he'll come to first floor, and then he'll come to second floor. User will drink water from second floor. That is the nearest way. Even though we have a drinking water in the third floor, but the nearest way to drink water is second floor. He'll drink water from second floor and go back from second floor to first floor to ground floor. This is what happened. So why SAP thought to keep the data in memory level? So if user wants to drink water, okay, that is the nearest way to drink and go back again. In the same way, SAP also thought that to keep the data in memory level. So if user wants to fetch the data extremely fast, if we place the data in memory level, okay, user will get the data extremely fast. So that's why SAP thought to keep the data in memory level. Why HANA is giving high performance if we keep the data in memory level? We have two reasons again. One is RAM is 10,000 times faster, 10,000 times faster than disk to process user request. This is one of the reason why HANA is giving high performance if you place the data in memory level. The second reason is data is very close to CPU to process user request. So if you place the data in memory level, okay, that is the nearest way to access by a user. That is one of the biggest reason. Okay, why HANA is giving high performance if you place the data in memory level means these are the two reasons. One is RAM is 10,000 times faster than disk to process user request. The other one is data is very close to CPU to process the user request. Data is very close to CPU to process the user request. So this is the reason why HANA database is giving high performance by a reason called in-memory database. Yeah, let me know have any questions on this. Anyone?
No, sir.
Oh,
I
thank
have a
you.
question.
Yes, please.
So you are telling that I will store the data in the RAM, but for suppose like disk space is more than RAM, right? So RAM cannot store entire data, right?
Once again.
No, sorry, in another database we have disk space is like for example we will use 1 TB disk space, but RAM we use like 32 GB or 56 GB. So how it will store the entire database in database to RAM?
Yeah, actually, even though if your disk storage is 1 terabyte or 2 terabyte, in real time, your RAM will be more. Your RAM will be 128 GB, your RAM will be 256 GB, your RAM will be 512 GB, your RAM will be 1 terabyte, your RAM will be 2 terabytes, 4 terabytes in real time. So we have the type of memory sizings, memory hardware infrastructures providing by cloud providers.
Okay.
సో మీరు ఎక్కడ చూసింటారంటే 32 GB 16 GB మీరు ఎక్కడ చూసింటారంటే మీరు అప్లికేషన్ సర్వర్లో చూసింటారు ఆ సైజింగ్. మీరు ఒకసారి మీ దగ్గర రియల్ టైమ్ సిస్టమ్ ఉంటే డేటాబేస్ యొక్క ర్యామ్ చూడండి ఎంత ఉంటుందో. గాట్ ఇట్? యా.
సో డిస్క్ లో ఉన్న ఎంటర్ డేటా RAM లో కూడా స్టోర్ అవుతుంది.
100%.
Oh, got it.
See, whatever the data we have in memory, the data is compressed. Actually,
Okay.
HANA database will support two types of tables. One is a row store table, the another one is columnar storage table. Okay, the columnar storage tables in memory level, they are compressed. If the tables are compressed, obviously the usage of memory will be very less, right?
Yes.
Yeah, still questions? Any questions on in-memory database?
No, sir.
Yeah. So this
No,
is the
sir.
first reason. Yes, someone is asking. Yes. Someone is trying to ask. Okay. So this is the first reason why HANA is giving high performance. So the reason is in-memory database. Coming to the second reason, columnar storage. HANA database supports two types of tables. One is row store table, the other one is columnar storage table. Okay, so first of all, what is a table? A table contains rows and columns. These are the rows. And these are the columns. A table contains rows and columns. Okay, it may be a columnar storage table, it may be a row store table. A table contains rows and columns. Okay, now, for example, if the table is row store table, okay, how user will read the data and how user will write the data? If the table is a row store table, user will read the data in row wise, will write the data in row wise. Okay, if it is a columnar storage table, user will read the data in column wise and will write the data in column wise. Reading the data in column wise and writing the data in column wise. So this is what the difference between row store table and columnar storage table. See, a table contains rows and columns, but the functionality, what we call, the technology is different. If it is a row store table, user will read in row wise and will write in row wise. If it is a columnar storage table, user will write in column wise and user will read in column wise. So that is the difference. Okay, first we'll go with the row store table, then we'll go with the columnar storage table. So the performance is giving, the high performance is giving through columnar storage table. Okay, so what is the disadvantage we have in row store table? So then only we can understand why columnar storage table is giving high performance. Coming to row store table, so the table name is tab 1 and the table type is row store table, and the table contains customer data, product data, amount data, and quantity data. And user is executing a statement, select customer comma amount from table 1. User requires only customer and amount data from table 1 table. So whenever user executes a statement, select customer comma amount from table 1. So this is the row store table, right? User will read in row wise. reading this row first, reading the second row first, reading the third row, reading the fourth row, reading the fifth row. Why it is reading all the rows? In all the rows, we have customer data and amount data. It is reading all the rows and will give the output. Okay, so to read one row, assume that it takes 1 second. How many rows we have here? Obviously, nine rows we have. It will take 9 seconds. Assume that if you have 100 rows like this, we have 100 rows, and user is executing same statement. Select customer comma amount from table 1. So it will read all the 100 rows. Why? Because in all the 100 rows, we have customer data and amount data. So to read 100 rows, obviously it will take 100 seconds. So whenever we execute a statement in row store table, so it is reading the entire table. Why? Because in all the rows of this row store table, we have that customer and amount data. So that's why it is reading the entire table. So for 100 rows, it is taking 100 seconds time to get the output. Now coming to columnar storage table. Same table, same data, but the type of table is a columnar storage table and the table name is a tab 2, and the same question, same statement what we executed for row store table, the same statement, select customer comma amount from table 2. Okay, this is a columnar storage table, right? So whenever user executes a statement, select customer comma amount from table 2, okay, it will read in column wise. Why? Because this is a columnar storage table. So it will read customer column and it will read amount column. Remaining columns are skipped. It won't read the unwanted columns. It will read only user requested columns. It will read customer column and amount column, and remaining columns are skipped. Okay, to read one column, assume that it takes 1 second. Okay, how many columns are there here? 4 columns are there. 4 columns are there. So whenever user executes a statement, select customer comma amount from table 2, how many columns it is reading? 2 columns. So obviously it will take 2 seconds. It will take 2 seconds. Assume that I have 100 columns like this. Assume that the last column name is country. Okay. So whenever user executes a statement, select customer comma amount from table 2. So user will read customer column and amount column, and remaining all columns are skipped. All columns are skipped. All columns are skipped. It will read only user requested columns. So here we have 100 columns. How many columns it is reading when we execute the statement select customer comma amount from table 2? It is reading only 2 statements. How much time it is taking? It is reading only 2 columns. How much time it is taking? 2 seconds. Now, if you compare with row store table, 100 rows, 100 seconds, 100 columns, 2 seconds. So which is giving high performance? When compared to row store table, column storage table is giving high performance. So this is one of the reasons why HANA database is giving high performance. The first reason is in-memory database, and the second reason is columnar storage table. And now coming to the third reason, massive parallel processing. Massive means huge amount of data. Parallelly processing that huge amount of data. Okay, so we may had a massive success party in general for a Pushpa movie. So they have given a massive success party. Massive means with a huge crowd, they have arranged a party. Okay, in the same way, massive means huge amount of data, parallelly processing that data. Okay, now I'll give you an example to make you understand that. So I have a building and it contains 5 floors. A building contains 5 floors, and I have assigned a person to this building to paint all the floors. I asked him to paint all the five floors. He's taking time to paint one floor, 1 day. One person, one floor is taking 1 day time. Obviously, 5 floors, 1 person, he will take 5 days. So he's taking long time to paint all the 5 floors, right? This is scenario 1. Coming to scenario 2. What I did in the first scenario, I have assigned only 1 person and he's taking long time to complete all these 5 floors. Now, coming to second scenario, I have increased my number of resources. I have increased the number of persons, nothing but increasing the number of resources. And I asked them to paint all the 5 floors. What they did, they parallelly painting, all of them are parallelly painting respective floor, and they are giving output in 1 day. 5 persons, 5 floors, giving output in 1 day. So which is giving high performance? Obviously, the second scenario is giving high performance. What we did to get the high performance, we increased the number of resources. So in the same way, now we'll go with a technical example. have a 10 billion records. Record means nothing but a value, and have only one core. Core means nothing but processor. So we used to have the dual core, octa core, hexa core, right? Core means nothing but a processor. So in CPU we have number of cores. Intel CPU supports 8 cores, and Helm CPU supports 10 cores. So we have different types of CPUs. So each CPU model will support a number of cores. Okay, here I have only one core. In HANA database, one core will scan 3.2 billion records in 1 second. So have 10 billion records and have only one core. 3.2 billion records in 1 second, 3.2 billion records in another second, 3.2 billion records in another second. Totally, it's taking time 3 seconds to read all these 10 billion records. This is first scenario. Coming to second scenario. So 10 billion records we have. Now I have increased the number of cores. Now I have 3 cores. Okay. In HANA database, one core will read 3.2 billion records in 1 second, right? So I have 3 cores now. So these 3 cores will read parallelly 3.2, 3.2, 3.2. Parallelly, they are reading all the records and giving output in 1 second. So which is giving high performance? The second scenario. The second example is giving high performance when compared to first example. In first example, we have only one core, but whereas in second example, we have 3 cores. So we increased the number of resources. However, we increased the number of persons in this general example. In technical example, we increased the number of cores to get the high performance. So this is one of the reasons why HANA is giving high performance. Okay, so we have discussed 3 reasons. One is in-memory database, the second one is columnar storage, and the third one is massive parallel processing. So because of all these 3 reasons, HANA is giving high performance when compared to other databases. So this is what called high performance. Now coming to analytical. Analytical means analyzing the user request. Whenever user executes a statement, whenever user executes an SQL statement, okay, HANA system will analyze the user request, what to read and what not to read. It will read only user requested columns and will skip the unwanted columns. So that is what called analytical. And coming to appliances. Appliances means, so here we have 3 reasons, right? One is in-memory database, columnar storage, and massive parallel processing, right? So to store the data in memory level, okay, and to read the data in memory level, or to fetch the data in memory level, so they have written some coding and programming, right? So this is software. To write the data in columnar storage, to read the data in columnar storage, okay, in the column wise, or to read the data in column wise, or to write the data in column wise, again, they have written some programming and coding, right? So these also software. Coming to massive parallel processing. So in massive parallel processing, we discussed about number of cores. Cores means nothing but CPU. CPU is nothing but hardware, right? So this is nothing but hardware. So the combination of software and hardware is nothing but appliances. So HANA means high performance analytical appliances. So this is what the abbreviation of your HANA, and this is what all the letters of your HANA. Okay, so now let me know have any questions. Whatever we have discussed so far. Any questions on this? Any questions?
No.
Yeah.